we now discuss the solution of a problem from the chapter Trigonometry that has appeared in the JEE Main Mathematics exam held on 29th January 2024 in the first shift. The problem is related to the concepts of trigonometric equations. The given question is, if alpha given as minus pi by 2 less than alpha less than pi by 2 is the solution of 4 cos theta plus 5 sin theta is equal to 1, then the value of tan alpha is, we are given 4 options. Right. We are given a trigonometric equation 4 cos theta plus 5 sin theta is equal to 1, and we are given alpha is a solution where alpha lies between minus pi by 2 to plus pi by 2. That means alpha belongs to the open interval minus pi by 2 to pi by 2 minus pi by 2 comma pi by 2. Then required to find the value of tan alpha. Now I will discuss the solution of this problem in 2 methods. First, we go for the first method, right? So given alpha is the solution of 4 cos theta plus 5 sin theta is equal to 1, where alpha belongs to the open interval minus pi by 2 comma pi by 2. Now what we do is we divide this equation throughout by cos theta, then we will get 4 plus 5 tan theta is equal to secant theta. And the division by cos theta will not pose any problems because minus pi by 2 and plus pi by 2 are not included in the interval. Right. So we take this and we square it, because we will get secant square theta, that we will convert into 1 plus tan square theta, and then you will get an equation in tan theta. Right. Squaring, we will get 4 plus 5 tan theta whole square is equal to secant square theta, and expand it. And for secant square theta, we write 1 plus tan square theta. Thus, we get this equation. So, 16 plus 440 tan theta plus 25 tan square theta is equal to 1 plus tan square theta. Now, simplifying, we will get 24 tan square theta plus 40 tan theta plus 15 is equal to 0. Right. So we are given alpha, where alpha belongs to the open interval minus pi by 2 to plus pi by 2, is the solution of this equation, of the given equation. Therefore, alpha will satisfy this equation. So 24 tan square alpha plus 40 tan alpha plus 15 is equal to 0. Solving for tan alpha using the formula minus b plus r minus under the square root of b square minus 4ac by 2a. Simplifying, we will get at the end minus 10 plus r minus under the square root of 10 by 12. Agreed. So we get tan alpha is equal to these two values, minus 10 plus square root of 10 by 12, comma, tan alpha is equal to minus 10 minus root 10 by 12. Let's look at our options. In our options, minus 10 plus root 10 by 12 appears as the against option 1, and this second one, minus 10 minus root 10 by 12, does not appear at all. So this second one does not appear anywhere, and the only one that appears is against option 1. Therefore, it is a very safe. Therefore, this is the solution. This is the solution. And so we write down the answer for this question is option 1. And because only one solution was present in out of the 2 solutions what we got, one of them is appearing in the options, the other is not. So therefore, safely we say our answer is option 1. You are happy, we are happy as teachers, and everybody is happy. Now what about this one? Minus 10 minus under the square root of 10 by 12. Is it also a solution? That we are not concerned. Anyway, we got the answer. So that is because of the options given like this is our answer, and that is the detailed discussion of the solution of this problem. Right. So as I told you that I will be talking about this problem in 2 methods. Before entering into the second method, what I will say is I will modify this given question only, this question only I will modify. I will modify in the options. So in the option 4, I will write down the second one, minus 10 minus root 10 by 12 also. So this option I will take out and I will put this option, minus 10 under the square root of 10 by 12. Then I will give the question. That is the modified question, and you have to answer this. That we will do in the next one. So that's the one. So we are modifying that question. The modification is in the options. So we are giving 1, 2, 3 options are same as in the earlier example, and option 4 we are putting a new option, minus 10 minus root 10 by 12. Remember that I have modified. This is the modification that I am suggesting. So you take that your example, alpha is a solution. As earlier, you divide by cos theta, and you square it and you simplify it. Then you will get 24 tan square theta plus 40 tan theta plus 15 is equal to 0 as in the earlier discussion. Right. And we are given alpha minus pi by 2 plus pi by 2 alpha lies is a solution of this equation. Therefore, 24 tan square alpha plus 40 tan alpha plus 15 is equal to 0 as in the earlier case. You will get tan alpha is equal to these two roots. So now tan alpha is equal to minus 10 plus root 10 by 12. I am writing that means what happens to the other one? What happens to the other root? So the other root is also appearing in the options. So minus 10 plus root 10 by 12, that's the option 1. Minus 10 minus root 10 by 12, that's option 2. These are all, both of them we got as the solutions. So what happens to this one? That is our question, and that is the discussion here. Note that, first note is, take alpha is equal to tan inverse minus 10 plus root 10 by 12. Now, if you compute, if you have a calci, you compute it, you will get minus 0.517925259. For this alpha, what happens to the given equation? So, for this alpha, 4 cos alpha plus 5 sin alpha comes out to be 1. Therefore, alpha is a solution. So this is alpha is a solution, and thereby tan alpha is this answer. So that's our correct answer. This is a solution, and tan alpha is equal to minus 10 plus root 10 by 12. Then what happens to the second one? The second one is also a solution according to this. And so you take the note to alpha is equal to tan inverse minus 10 minus root 10 by 12, that is equal to minus 0.8315566276. So this alpha is very much lies in this interval, minus pi by 2 to plus pi by 2 also. But for this alpha, what happens tan alpha. So for this alpha, 4 cos alpha plus 5 sin alpha is minus 1, which does not satisfy the given equation. So you are getting as a solution for this equation. But if you take the alpha, that alpha is not satisfying the given equation. So that means to say this tan alpha is equal to minus 10 minus root 10 by 12. We have to reject it. This alpha is not a solution of the equation, and tan alpha is equal to minus 10 minus root 10 by 12 is rejected. So that's the reason why we reject the other one. So what is this? Tan alpha is equal to minus 10 minus root 10 by 12. That's also a solution. Such a solution is called extraneous solution. Such a solution is called extraneous solution. So this is the option 4. What we have changed is only appears to be a solution, but it is not a solution. It's not a solution. This is how we have rejected it. So the answer to this question is option 1. That is the detailed discussion of the solution of the problem. I am sure that you have understood our argument here and you liked the modification also. Now we turn to the method 2. So that is our question, and we go for method 2, and we have 4 cos theta plus 5 sin theta is equal to 1. In this we don't divide and square. And why that extraneous solution resulted in the previous slide? It is because that you have squared. By squaring, you got a solution there, but that is not a solution. It is an extraneous solution. Extraneous solution because of squaring. And I don't square here. I don't divide also here. So what I will do is I will divide throughout by or multiply throughout by 1 by root of 4 square plus 5 square. Multiply throughout by or divide throughout by root of 4 square plus 5 square. In other words, divide throughout by multiply throughout by 1 by root 41. That will be 4 by root of 41 cos theta plus 5 by root of 41 sin theta is equal to 1 by root of 41. This is the equation 1. Now let sin beta is equal to 4 by root 41. These steps are very familiar to us. We have done it quite a good number of times. When sin beta is equal to 4 by root 41, then cos beta will be under the square root of 1 minus sin square beta. That will come out to be 5 by root of 41. So the above equation now becomes sin beta cos theta plus cos beta sin theta is equal to 1 by root 41. Is this equation solvable for theta? Yes, it is. So this is sin of beta plus theta is equal to 1 by root of 41. Is this equation solvable? Yes, this equation is solvable because 1 by root of 41 is less than 1 and it is sin of beta plus theta. Right. Now let us now write down the general solution. Beta plus theta, sin of beta plus theta is equal to 1 by root of 41. Then beta plus theta is equal to sin inverse 1 by root of 41. It's the principal value. What we have written here is the principal value. Now we write it's a general solution. The general solution for beta plus theta is equal to n pi plus minus 1 to the power of n into the principal value sin inverse of 1 by root of 41. N belongs to z. Z is the set of integers. Then send this beta to the other side. Theta will be equal to n pi plus minus 1 to the power of n into sin inverse 1 by root of 41 minus beta. What is beta? Sin beta is 4 by root 41. Beta will be sine inverse 4 by 41. Minus sine inverse 4 by 41. This is also principal value. So this is the general value for theta. We continue our discussion in the next slide. Agreed. We have that general value, and let n is a integer, and let us take n is equal to 0. Then what do you get? N is equal to 0. Then it is 0. It is 1 only. This will be equal to, theta is equal to alpha only. Alpha only. And what will be alpha? Alpha is equal to sine inverse 1 by root 41 minus sine inverse 4 by root 41. That is the same alpha, minus that lies between minus pi by 2 plus pi by 2, because we have taken only principal values there. So alpha is equal to sine inverse 1 by root 41 minus sine inverse 4 by 41. Oh, very good, very good. Now take the tans on both sides. Tan of alpha is equal to tan of theta 1 minus tan of theta 2 by 1 plus tan of theta 1 multiplied by tan of theta 2. Now simplify, we will get 1 by tan of sine inverse of 1 by root 41 is 1 by root 40 actually. So that is 1 by 2 root 10. And tan of sine inverse of 4 by root 41 is 4 by 5. Please compute this. Please compute this. Putting this as theta. This as theta. So compute it. Then it will be 1 plus 1 by 2 root 10 into 4 by 5. Now clear the LCMs. Then you will get 5 minus 8 root 10 by 10 root 10 plus 4. Agreed. Now rationalize the denominator. The denominator factor is 10 times root 10 minus 4 by 10 times root 10 minus 4. Multiply and divide by that. Then when you multiply this one, 100 into 10,000 minus 16. That is, the denominator will be this one. And when you multiply this one, you will get 50 root 10 minus 8 root 10 into 10 root 10 is 800 minus 5 4s are 20 minus into minus plus 4 8s are 32 root 10. Right. In the denominator you will get 9 and 84. In the numerator you will get 82 root 10 minus 820 by 984. And observe that 82 is common in the numerator and denominator. If you cancel, 82 into 12 is 9 and 84. Then you will get root 10 minus 10 by 12. By 12. So that is tan alpha value. And we have got only one answer, unlike the two answers in the earlier discussion. So we got only one, and that is the solution. Let's look at our options. Our answer appears against option 1. Therefore, the answer to this question is option 1. Option 1. And this discussion is very, very elegant and very nice for the representation also. And there is no need of rejecting the second answer for tan alpha, as in the case of the earlier discussion, and that turns out to be an extraneous solution. Here we have not divided, or we have not squared all. We have not squared, and that is why we did not encounter the extraneous solution. We got exactly one solution. That solution is this one, and that is the advantage with this kind of an argument. And I am sure that you have liked this argument, second method, and I am sure that you are interested in the solutions of such proofs. So that is the detailed discussion of that question that has appeared in the JEE Main exam held on 29th January 2024 on trigonometric equations. I wish you all the best. Thank you.